For this video, we're gonna talk about density and specific weight. We're gonna start with density. Basically, density is defined as the mass per unit volume. It tells us how compact the mass in a substance or an object of a given volume is. For example, we have here two systems, A and B. Which of these two is more dense? Assuming that they contain same type of particles and have the same volume, we can simply go by the definition of density, which is mass per unit volume, to conclude that system B is more dense, since it contains more particles, giving it more mass and making it more compact than the other system. The mathematical representation for density is given by this equation. Density is equal to mass divided by the volume, where density is denoted by the Greek symbol rho, and for mass we have the small letter m and capital letter B for the volume. If we recall the property specific volume and its equation of volume per unit mass, we can conclude that it is the reciprocal of density, giving us another possible equation. For density we have 1 over specific volume, and for specific volume we have 1 over density. The dimension for density is mass per cubic length, and these are the units for density in different unit systems. For SI, we have kilogram per cubic meter. For CGS, we have grams per cubic centimeter. For British gravitational, we have slug per cubic feet. And for English engineering units, we have pound mass per cubic feet. Another property that is related to density is the specific gravity or relative density, which is the ratio of the density of a substance to the density of some standard substance at a specified temperature. Usually water at 4 degrees Celsius, for which the density is 1000 kg per cubic meter. And here is the equation for specific gravity. Note that this is a dimensionless quantity because simply looking at the equation we can see that the units of density will cancel each other. After all, specific gravity only tells us how dense a substance is relative to other substance, and in this case, water at 4 degrees Celsius. If the value of n that we get is less than 1, it means that the water is denser, and the substance will probably float if it is put in a water mixture. And if the value of n that we get is greater than 1, it means that the substance is denser, meaning it will sink if it is mixed with water. So now we're gonna solve a simple problem. A student is given a metal sphere about the size of a softball and asked to identify what type of metal it is made of. It has a radius of 5 cm and a mass of 5.915 kg. And we have on the side the short list of densities of different metal in CGS units. So here is our equation. And let's list down the given data. We have mass of 5.915 kg, and we have a radius of 5 cm. We have a mass, but we have no volume. But it is a sphere, and the volume of sphere is given by this equation. 4/3 pi multiplied by radius to the 3rd power. And let's input the radius. 4/3 pi multiplied by 5 cm raised to the 3rd power, and we'll get 523.598776 cubic centimeters, or approximately 523.6 cubic centimeters. And now we have the volume. For this problem, we are using CGS system of units, so we still need to convert the mass of kilograms to grams. So 5.915 kilograms multiplied by the conversion factor, and we'll get 5,915 grams. So we have all our needed data. We can now finish the problem. We'll write the equation again, and we just needed to input the data that we got. So 5,915 grams divided by 523.6 cubic centimeters, and we'll get 11.297 grams per cubic centimeters. Looking at the table, the nearest value for our density is lead with 11.36 grams per cubic centimeters. So it's safe to assume that the sphere is made of lead. And that's it for density. Now let's go to specific weight. Specific weight is the weight per unit volume. And since weight is a force, its dimensions are force per cubic length. And it can be expressed by this equation. Specific weight is equal to density multiplied by the acceleration due to gravity, where the specific weight is denoted by the Greek symbol gamma, and rho for the density, and small letter g for the acceleration due to gravity. And since density is the reciprocal of specific volume, we can also use this equation. Note that the letter v in the dividend is lowercase, meaning it is a specific volume. But if we just go by the meaning of specific weight, we can have this equation. Weight divided by volume. So these three are some equations for solving the specific weight. Here are the units to be used in this property. For SI, we have Newton per cubic meters. For CGS, dyne per cubic centimeters. For British gravitational, we have pound per cubic feet. And for English engineering units, we have pound force per cubic feet. And for our final example problem, 4 cubic meters of oil weighs 31.5 kilonewton. Calculate its density, specific weight, and its specific gravity. First, let's write down the given data. For volume, we have 4 cubic meters, and for weight, we have 31.5 kilonewton. So we have volume and weight. We can easily calculate the specific weight. So this is the equation we're using for this type of problem. Specific weight is equal to weight divided by volume. So let's input our data. For weight, we have 31,500 Newton, and for volume, we have 4 cubic meters. And we get 7,875 Newton per cubic meter. So we have the specific weight. And the next step is to solve for density. We have volume, and we can calculate for the mass. But it is quicker to use this formula, because we have the value of specific weight, and we can assume the gravity to be 9.81 meter per second squared. So let's put the density on the left side, and the others on the right side, and we're gonna get this equation. And let's input the data again. For specific weight, we have 7,875 Newton per cubic meters, and for gravity, we have 9.81 meter per second squared. And we get 802.75 kilogram per cubic meters. And now, we can compute for specific gravity. Remember the equation earlier. The density of the substance over the density of water at 4 degrees Celsius. So let's just input our data again. 802.75 kilograms per cubic meter for the oil, and for water we have 1000 kilogram per cubic meter. Dividing this, we get 0.80. Meaning that the oil is less dense than the water. To prove this further, you can put oil in glass with water and you'll see that it will float. So that's it. Thank you for watching.